Hello there and welcome to today's class. In today's class, we'll be solving over 10 most repeated post-UTME questions on physics. The first question we have today says, a uniform metal rod 2 meters long is balanced horizontally on a fulcrum, placed 0.5 from one end. If the weight of 30 newtons is hung at the shorter end, what weight must be hung at the longer end to maintain balance? Now, note that to maintain balance, the sum of clockwise moments must be equal to the sum of the anti-clockwise moments. To maintain balance, clockwise moments must be equal to what? The anti-clockwise moments. From the question, let's set up a free body diagram. It says a uniform metal rod 2 meters long. Let us assume this is the metal rod and the length of this metal rod is 2 meters. This is the metal rod. It says it's balanced horizontally on a fulcrum placed 0.5 from one end. So let's assume it is placed here. This is a fulcrum. To maintain balance, it is placed at 0.5. So the distance from here to here is what? 0.5 meters. They say from one end, if the weight of 30 newton is hung at the shorter end, this is the shorter end, right? A weight of 30 newton is hung at this point. What weight must be hung at the longer end to maintain balance? So the weight at this longer end is unknown. They say we should find it. So that's what this question is talking about. Recall that moment is equal to what? Force times perpendicular distance. Let's say distance. Moment is equal to force times distance. Now, from the question, we said something that to maintain balance, clockwise moments must be equal to anti-clockwise moments. Clockwise moment meaning from this point is moving like this. If it's moving this other way, it's anti-clockwise. This way is clockwise. This other way is what? Anti-clockwise. Now, for clockwise moments, we have it moving this way, which is the force times the distance. So we have force times distance. Here we have is equal to the force times the distance, which is, if we call this F1 and we call this F2, it means F2 times the distance. F2 times the distance here is what? 1.5. Don't forget, this is 0.5 meters. This is 2 meters. 2 meters minus 0.5. It means from here to here is what? 1.5 meters. So it's the force, which is F2, the force acting here, times the distance from here to the fulcrum, which is 1.5. So we have F2 times 1.5. For anti-clockwise moments, we have this times this, right? The force here times this. So we have F1, which is 30 newtons. 30 times the distance, 0.5. We have that F2 times 1.5 is equal to this. Clockwise moment is equal to anti-clockwise moment. So we have 30 times 0.5. 30 times 0.5 will give us what? 15, right? 15. 2 times 1.5 gives us 1.5 F2. If we make F2 the subject of formula, F2 becomes 1.15 divided by 1.5. 15 divided by 1.5 will give us 10. Don't forget the weight is in what? Newtons. Therefore, F2, which is the weight hanging at the longer end of the metal rod, is equal to 10 newtons. Our correct option here is option A, 10 newtons. Question 2 says, a gas occupies 4.0 cubic meter at the pressure of 2.0 times 10 raised to the power 5 Pascal. If the pressure increases to 4.0 times 10 raised to the power 5 Pascal, what is the new volume, assuming constant temperature? Option A, 2.0 cubic meter. Option B, 4.0 cubic meter. Option C, 6.0 cubic meter. And option D, 8.0 cubic meter. Now, let's write out the given parameters. From the question, we are given a gas occupies a volume, initial volume, V1, is equal to what? 4.0 cubic meter. See, at the pressure of what? 2.0 times 10 raised to the power 5 Pascal. So we have P2 is equal to 2.0 times 10 raised to the power 5 Pascal. You see, if the pressure increases to 4.0, this is P1. If it increases, you have P2 is equal to 4.0 times 10 raised to the power 5 Pascal. What is the new volume, which is V2? It's unknown. Recall from Boyle's law that P1 V1 is equal to P2 V2, right? We know our P1, we know our V1, we know our P2, but we don't know our V2. This is from Boyle's law. If we make V2 the subject of formula, we have that V2 is equal to P1 V1 all over P2. V2 is equal to P1 is what? This value, 2.0 times 10 raised to the power 5 Pascal divided by times our V1, which is what? 4. So we have 4.0. Our P2 here is what? 4.0 times 10 raised to the power. So we have 4.0 times 10 raised to the power 5. V2 here is equal to 10 raised to the power 5. We cancel 10 raised to the power 5. We're left with 2.0 times 4.0 divided by 4.0. 2.0 times 4.0 gives us 8.0 divided by 4.0. 8.0 divided by 4.0 will give us 2.0. Therefore, V, which is the final volume or the new volume, V2, is equal to 2.0 cubic meter. Therefore, the correct option here is option A, 2.0 cubic meter. Question 3 says, how much heat is required to melt 500 grams of ice at 100 degrees Celsius? Take the latent heat of fusion of ice to be 334,000 joules per kilogram. Option A, we have 167,000 joules. Option B, 334,000 joules. Option C, 66,800 joules. And option D, 133,600 joules. Now, solution. Let's write out the given parameters. From the question, we were given mass. The mass of the ice will be what? 500 grams. If we convert from grams to kilograms, don't forget, mass is in kilograms. So converting from grams to kilograms, we divide by 1,000. So you have 500 divided by 1,000. This will give us 0.5. Our mass here is 0.5 kilogram. You see, at 0 degrees, so they give us temperature to be 0 degrees. They give us the latent heat of fusion of ice to be 334,000. So we have latent heat to be 334,000 joules per kilogram. You see, the question says how much heat is required to melt. So the heat required for fission is unknown. Now from the formula, the heat required for fission is given by this formula. Q is equal to mL, where m here stands for the mass and L here stands for the latent heat of fission. Q here is equal to m, we have 0.5 times L. L from the question was given is a constant, 334,000 joules per kilogram. This is in kilogram. Now Q is equal to kilogram here, we cancel kilogram, the girls. We're left with 0.5 times 334,000 joules will give us 167,000 joules. Therefore, the heat required to melt 500 grams of ice at 0 degrees temperature is option A, 167,000 joules. Question 4 says, a 2 kg object is wheeled in a circle of radius 1.5 meters at 6 meters per second. What is the centripetal force? Option A, 12 newtons, option B, 24 newtons, C, 48 newtons, and D, 72 newtons. Now, we know that centripetal force is the force required to keep a body moving in a circular path. When a body moves in a circular path, it needs a force acting towards the center of this path to keep it moving, to keep it moving continuously in this path. It needs a force acting towards the center. This force acting towards the center now is called the centripetal force. And mathematically, it is expressed as F is equal to mv squared over r, where m is the mass, v is the velocity, and r is the radius. From the question, what were we given? It says a 2 kg mass of object. So mass of the object was given as 2 kg. It says wheeled in a circle of radius. They give us radius r to be 1.5 meters at 6 meters per second. Velocity is equal to 6 meters per second. They say what's the centripetal force? F subscript C, the centripetal force is unknown. Now from this formula for centripetal force, if we substitute these values into this equation, we have that centripetal force is equal to mv squared. Our m here is what? 2 kg. 2 times our v here is 6 all squared divided by r. Our r is 1.5. This will give us 2 times 6 squared, 6 multiplying itself 2 times, which will give us 36 divided by 1.5. 2 times 36 will give us 72 all over 1.5. 72 divided by 1.5 will give us 48 newtons. We have gotten the centripetal force now to be what? 48 newtons. from the options here, the correct option here is option C, 48 newtons. Question 5 says, a coil of 100 tons experiences a change in magnetic flux of 0.02 Weber in 0.05 seconds. Calculate the induced EMF. Option A, 20 volts. Option B, 30 volts. Option C, 40 volts. And option D, 50 volts. I'll repeat the question again so you. A coil of 100 tons experiences a change in magnetic flux of 0.02 Weber in 0.05 seconds. Calculate the induced EMF. The EMF, electromotive force, is given by this formula. N times the change in magnetic flux all over the change in time, or the time interval, where N here stands for the number of coil, change in magnetic force here, and D stands for the time interval. EMF is equal to, from the question, is unknown. They say we should find the what? EMF, the induced EMF, which is the electromotive force. They gave us the number of tons to be 100, so we have N is equal to 100 tons. That's the number of coils. It expresses a change in the magnetic flux of 0.02 Weber. So change in magnetic flux is given as 0.02 Weber. And we have the time interval to be 0.05 seconds. If we substitute this into this formula, we have that EMF, which is the electromotive force, is equal to N. N here is what? 100. 100. The change in magnetic flux is given at 0. Times 0.02 Weber divided by the time interval, which is 0.05. This will give us 100 times 0.02 divided by 0.05 will give us 0.4. 100 times 0.4 gives us 40 volts. Don't forget, EMF is measured in what? Volt. The unit for EMF is volts. Therefore, the EMF, which is the electromotive force induced, it's 40 volts. Our correct option here is option C, it's 40 volts.